EmonaTIMS Freewire. Now this is where we can deliver telecommunications teaching, which looks exactly the same as our modular approach, our premium product of individual modules, except that the modules are all inside one of these units, and you can access it and make all the connections yourself remotely, multiple students at the same time. So just imagine your entire lab class could be accessing telecommunications labs, 30 or 40 experiments at the same time from one unit, just sitting in the corner on a LAN. So here is the same format. As you can see, we have a number of empty slots. We have our instrumentation down the bottom. So let us look at the menu to choose from. Let us look at, here is the menu: adders, amplifiers, exclusive OR, function generators. Let's put a function generator down. Let's look at that signal. Okay, I've made a connection. Now I'm going to change the amplitude. Okay, and there you can see it takes about 1 to 2 seconds, and my request to the server has sent me back the signal that is coming from the hardware. Now I'm going to put down what I call master signals, which is where we have our standard oscillators, and I'm going to put down an adder. Now I'm going to take my sinusoid into the adder. I'm going to look at that with my B channel and increase the amplitude. Okay, so there's my 2 kilohertz signal. Now I'm going to change my function generator to DC, and I'm going to connect it to the adder, and I'm going to increase the gain on my DC, and I'm going to change the DC value from 0 to something bigger than that. So here you can see I now have a DC value, and you can see that the blue signal, the output went down. So, okay, my output went down, my DC level went up. Okay, you can see that changing. So now I'm about to do amplitude modulation. So now I'll put down a multiplier. Multiply, we have 4 multipliers. So I'm going to multiply that message with a carrier, 100 kilohertz carrier, and I'll look at that on the D channel. Okay, and you can see there's some terrible aliasing there, as you would expect from a scope. So I'll change the time base. Okay, change the time base to a more appropriate time base, and there you can see we have some amplitude modulation, which I am controlling in real time. There we have like 100% modulation approximately. Students would take measurements, period, amplitude. They could look at the spectrum. There's the spectrum as you would expect. Now you can see the carrier and the 2 sidebands at 2 kilohertz. Let's put in a slightly more interesting message. Let's select a VCO. Here's the VCO. As I do this, I'm actually selecting real physical modules, and we will replace that. We'll take the output of the VCO and put it into the adder. Now you can see I have an inappropriate frequency, so I'll switch to low, and then I'll vary my frequency. And as I vary my frequency, you can see the AM change, and you can see the sidebands change. I could switch off the time base. I could switch off the frequency. Okay, so look, quickly and easily, you can see that I've selected 1, 2, 3, 4, 5 physical modules, which are mathematical functions, and I patched them together. These are real physical hardware connections, and we implement these physical connections using a massive analog cross-point switch inside this unit. So when you have Freewire in your lab, you have a suite of analog and digital blocks. You have a massive cross-point switch and a 4-channel scope, which allows you to deliver multiple experiments to your students. These can be saved locally or privately, and they can be delivered to students. Students can pull up the experiment that you have made for them and explore it, or they can create the experiments themselves over time. So that is a quick introduction